Hey everybody, we are looking at this problem binary tree level order traversal. Given the root of a binary tree, return the level order traversal of its nodes, that is from left to right, level by level. What does that mean is let's traverse this first, let's travel this first, and then let's travel this. And every level, return this in the form of a list, something like this. So 3 would be one element of the list, which is itself is a list. 920 is another level, and that is one of the element in the list, and 15.7 another list as part of the output list. So to solve this problem, let's make certain observations. What we are actually doing is we are printing all the elements at a distance of 0 from 3 from the root basically, and then we are printing every node at a distance of 1, and then we are printing every node at a distance of 2. This is called a breadth first search algorithm. If you know the in order, pre order, or post order traversal, we were doing a depth first search in that case. We were printing everything in this subtree, and then we were printing everything in this subtree. In this case, however, we are supposed to print this particular level first, which means what if I had elements here? Let's say there was a node here, let's say there was a node here. Getting to 9 and 20 is fairly easy. The left and the right node of 3. In 9 and 20, I want to print it like this, which means I look at 9 and then I move on to 20, which means I lost this data. Now I'm at 20 and I cannot go back. We should not be writing an algorithm like that. So I need a way to traverse these nodes once I have moved on to the next node. So to solve that issue, we are going to use the queue data structure. This queue data structure has the capability to print, to store these values which can be used later in order. The first in, first out property of queue helps us do that. So when we are at 3, we input 9 and 20. So based on the first in, first out, we are supposed to execute 9 and 20 first. And then these elements come in, and these elements go after 20. So they are processed after 20. So this, and this is processed after 20. Let's take an example and see how this level order traversal would work. Let's say I have this example. This is a binary tree and we have a queue. First thing, we would initialize this queue with the root of the tree. So 1 goes over here. Next, we would iterate through this queue and append our result to this result array. So this queue has element 1. Let's take this element 1 out of the queue, append it in the result, and every time we remove an element from the queue, we append its children. So children of 1, 4 and 2, 4 and 2 goes to the queue. So 2 over here, 4 over here. Next, we would iterate to the next element. We were iterating on this. Let's go to the next element 2. This 2, we can take it out of the queue to the result, append its children, which is 3 and 5. 3 and 5. goes here. You can see we would now traverse 4, not 3 and 4. So we are at 4, take it out of the queue. This becomes part of our result, and its children are appended over here. So 6 and 7 are in the queue. We go to 3 next time. 3 taken out of the queue to the result. It does not have any children, so we don't have to append anything. Very similarly for 5, we can process this thing, take it out of the queue, make it part of the result, and 6, 7 exactly the same. 6 and 7. So these are all processed. So you can see we do have a level order traversal. 1 is printed first, 2 and 4 next, 3, 5, 6, and 7 after that. So this is the level order traversal. Now in this question, there is something different we have to do. We are supposed to result a list of list where every element is a list representing the level. So this is not the response we want. We want something like 1 separate, 2 and 4 separate, 3, 5, 6 and 7 separate. These are the 3 levels and they should be a list of their own. So to modify this solution to return us something like this, we can there can be many methods, but there is one very simple way is to use another list. So the for children, use another list for children. So let's say I have this as queue initially. When I traverse this queue, I don't really care if the element is a parent or a children. This time I want to care for that. For that, let's create another list. Let's call it the next queue. So when we process 1, its children are not appended to the existing queue, but appended to the next queue. In this way, we know which are the parent and which are the children. Once we are done with processing the parent, the queue becomes equal to the next queue. All the parents replaced with their children, and now they are the parent for any next node over here. So this would be able to give us a response like this. Now this would be the basic algorithm of solving this problem. Let's take a look at the code implementation to understand it better. So I am here in the code editor. I have this function given which has an input of root, which this is the root of the binary tree, and we are supposed to return a list of list. The first thing, I would like to create a queue and initialize it with root. So queue equals to this empty queue, queue dot append, initialize it with root. And I'm supposed to enter the root of a variable type tree node. This is not the value we are supposed to input here. Next, I would like to create an empty result. This would be the result we would return. So let's iterate through the queue while queue. So until queue is empty, let's keep iterating through it. Next, I would like to store the result of every level. This is basically 3, 920, and 15.7, something like this. So this is our sub result. Let me just call it level, and this would be empty in the beginning. Next, I would like to create a next queue. This would store all the children. So this would be empty in the beginning. After that, let's iterate through the queue. So for node in queue, I am processing every element. So I would just append it in the result. So level is our local result. So level dot append node dot value. This time I need a value here. Now this is processed. If I have a left child or a right child, I want to input that in the next queue, which would eventually become queue. So if node dot left exists, then in the next queue, add this node dot left. Very similarly, if node dot right exists, in the next queue, append this node dot right. So this way we have processed the entire queue which had the parent. So let's replace parent with the queue. Sorry, with the children. So queue, let's empty it out. Queue, assign it to, or let's do the extend to be safer in Python. Next queue. So basically the values of next queue goes to queue this time. Now if I have not really appended this level into my result yet, I need that in the result. So if the level exists, because there is a possibility level is empty for the leaf nodes. So if there is a level, then result dot append this level. Now I think we should be done with this. I can return result from here. There's just one condition we are missing. In this problem, root can be empty. So we have to take care of that base condition. So if not root, if we have an empty tree, we return an empty result. So that would be an empty list. Let's try to run this code. Let's submit it. So we have a solution. If this video was helpful to you, please consider subscribing for more such content.